Hi and welcome to Tech Lesson 6. Now, in this lesson, we're just going to give this is going to be a very basic overview of the important parts of is. But as I said, very basic. So let's start with the areas and router roles. So it uses the Dijkstra algorithm the same as OSPF, but the areas and the router roles are completely different. So let's go through it a minute. So is uses different areas, okay, where the entire router sits in one area, not just one of its interfaces like OSPF. So if you remember with OSPF, an area border router, for example, will have an interface in one area and another interface in the backbone area. In the case of is there's no backbone area per se like OSPF. The backbone is there, but it's formed by a string of routers. Okay, so let's have a look at the different types of router roles. So there's a level 1 system, and as it says here, it's an intra-area router. It only knows what the local area looks like, and it will only learn prefixes from its own area. It creates a level 1 linked state database and the shortest path first tree for the area. Okay, so it can only learn from what is within its own area at a level 1 perspective, or from a level 1 perspective. So let's have a look at what a level 2 system is. Well, it's a backbone router, and as we said further up, the backbone is formed by a string of routers. So it knows all the intra-area and inter-area routes. So it creates a level 2 links database and SPF tree for the backbone. Okay, so it knows both. Okay, so a level 1-2 system, this would be the equivalent of an area border router in OSPF. So this is a router that performs both roles. Okay, so it creates a separate level 1 and level 2 link state database and 2 SPF trees, one for each database. So this would sit between your level 1 systems and your level 2 systems so that they can communicate and share routing information. Okay, without this, they can't. So the next point that we have to move on to here is what's called a net address. Okay, this is an address that is required for is to work and to function on a router. So it's an Nsap net address. Okay, so an Nsap, which is a network service access point, and a net or network entity address looks, well, it doesn't look similar to the following. It is like the following. Okay, so 49.001.002.002.002.0022.00 looks complicated, but it's actually not. All the 49 indicates is that it's a private network. Now, just about 99% of networks will begin with a 49, okay, because they're all private, internal. You don't really want other people knowing about that information. And most is implementations start with this. The next 4 digits are the area. So in this case, it's area 1, but it has to be 4 digits. So we 0001. Just replace the other 3 digits with zeros. Now the next 3 set of 4 digits that we've got here is 2222. Again, it has to be 4 digits. Now what we tend to do is we need to make this intuitive. It can be whatever you want to be, but it has to be unique to that particular router that you're going to put this on. So in this case, what I've done is I've taken one of our routers that had the loopback address of 2222 and just implemented it into this. So fill in the blanks, 0002.0002.0022. We could have in there, for example, 192.1.68.0001, which would indicate 192.168.2.1. Always try and fit your loop back address into this. And the reason for that is from a troubleshooting perspective, the TLVs, which you don't have to worry about at the moment. It just means type, length, value, but don't worry about that at the moment. But you can understand which system they came from a troubleshooting perspective. If you just put any number in there that's not intuitive, that doesn't show you where it's from, troubleshooting will become quite complicated, because you then have to work out where the packets are from or where the TLVs are coming from. Okay, so that's enough of that for the moment, because this is not an is tutorial. There will be a tutorial later on in later lessons, but for now, this is just a basic overview of it. Okay, so what we're going to do next is we are going to start configuring up 4 routers, and the topology comes next. So this is the topology we are going to utilize, which consists of our aggregated Ethernet groups, which is going to be 00 from London to Bristol, and A1 to A1 between London and Leeds, and A1 between Bristol and Edinburgh. Our loopback addresses are going to be 2 for London, 3 for Bristol, 4 for Leeds, and 5 for Edinburgh. Our /30s are all separated here into their corresponding networks, and our net addressing will be consistent with what we just discussed in the presentation, of the 49 being the private network, the 1 being the area, the next 3 sets of 4 digits will be the loopback address, and the end 2 basically is 00. It's nearly always a 00. It means this node. Okay, so this is the network we're going to be working with. You might want to pause it at this point if you want to have a look at the topology and design it yourselves. So without further ado, let's go ahead and configure everything. So let's start our configuration with London. Now, I've done some advanced configuration here so that we're at the same position as we were in the previous lessons on all 4 systems. So London, Bristol, Leeds and Edinburgh. So let's have a look at the configurations first that you can see. So as you can see, I've set the login classes. I've set the user login, set the system host name, SSH, the aggregated devices, and we've included now AE1, as can be seen here. Okay, so we've also configured AE1 with the IP addresses and the loopback address. Okay, so let's do a show interfaces to so that we can see both of those AE interfaces, and they're both there, look, okay, and they're in an up position. So the address we've got this end on our interfaces is 1.2, so let's ping 1.1 first. Let's make sure we have communication. And the opposing address of .5 is going to be .6, so let's make sure we can ping that as well. Okay, so we have communication through the AE links as we expect to have them here. Now, the one thing we won't have is if we do a show route, we are currently on the London router, and we know from our configuration, if we're on London, let's just zoom in a little bit for you. If we're on London, we know that our loopback interface is 2, and on Leeds it's 4. So let's just have a look and see where we are with regards to that. Okay, and there is no route, and there won't be any route in there. Okay, so let's start configuring up our is. Okay, so let's go into edit mode, configure or edit, doesn't really matter which. So the first thing we're going to do is we are going to set on our loopback interface, we're going to set our ISO address. You remember that's our net address. Okay, so our Nsap net address. So set interfaces LO0, and it's the same again, family, sorry, unit 0, family. So let's have a look at what we've got options wise. Well, we know they're ISO addressing. So we have to use ISO here. Okay, so we do family, ISO, address. Now comes this address. So we start with 49. You remember area next, 0001. And now we make up the next three sets of 4 digits with our loopback address. So here we're going to go 0002 because you remember it has to be 4 digits. 0002 0022. That tells me that the IP address is 2222 and it's this node 00. That is our ISO address configured. So let's commit that. Now, the next thing we have to do is any interfaces that we want to be included in the is routing tables, we have to apply those into the is protocol as well as put the ISO on the actual interface itself. Now remember, because we're using aggregated Ethernet grouped interfaces, we have to do this on the AE interface, not the physicals. So we do set interfaces AE 0, unit 0, family, ISO, and that is it. We also need to put this on AE1. Okay, so we can commit that. That isn't the end of it though, because as I'm sure you're aware with Juniper systems and any other systems, we have to set the actual protocols themselves. So now we do set protocols is, and we put our interfaces in this. Interface AE0, and we have to put the .0. And AE1.0. And we can commit that. Okay, now there's a couple of other points that we're going to look at first. Is currently at the moment with that configuration, we are configuring this router as a default level 1, level 2 router. So how do we disable it if we only want to be in a certain level? Well, this is how we do it. We do set protocols. I'm not going to do it. I'm going to leave them as level 1, level 2s for the moment. Okay. Once we get into is deeper and we get a more complicated network, then I'll show you how it all works together. So, but for the moment, I'll just show you how we can disable it. So let's say we only want them to be level 1. So we do level 2, and let's look at our options. And look, we have disable is on this level. So if we were to put in there disable, we are disabling this router from participating in level 2. Okay, it will only be a level 1 router. And if we were to change that to level 1, then we would be disabling level 1 and it would only be participating in level 2. Okay, and that's how we can configure that to be disabled. We can also do authentications on these levels as well. But again, that will be done in a later lesson. So we use the authentication key and a password, and we use the authentication type. Okay. And that's how we can do that as well. As I said, we'll do this on a more in-depth is. At the moment, this is a very, very simple one to show you. Okay, so if we exit and we do show root, currently at the moment we have our routes as shown here. But you'll notice we don't have the opposing sides 4444 network. Okay, so what we're going to do now is we're going to go on to leads, because this is the one that we want to look at initially, and we'll log on and again show configuration So as you can see, it's a very basic configuration there, but here's our 4444. Now, if we were to try and ping 2.2.2.2, there is no route there, and it just doesn't exist. We can still ping 192.168.1.5 because that's the other end of our aggregated Ethernet interface. Okay, so let's configure it up on this one as well. So firstly, set interfaces LO0 unit 0 family, and remember it's ISO, and we're going to put in our address, our net address, again 49 private network, and we want it to be the same area. So we put in 0001. Now the next three set of 4 digits, we're going to utilize a unique address for this system again of the loopback address. So this time it's 1, 2, 3, and because we're using 4444 and 00 on the end to indicate this node. So we'll commit that one. Okay, and what we're going to do now is we're going to set our interfaces into ISO as well, into the family ISO. So it's AE1 is all we've got on this system. So we just need to put that into family ISO, and then we need to set protocols is interfaces AE1.0. But don't forget, we also need to include our loopback interfaces. So we're also going to set LO0.0. And we're going to commit that. And let's have a quick look. If we do a run show route 2.2.2.2, we still don't have it in there at the moment. Okay, and that's because on London, if you note in our configuration, if we do a show, so this is a bit of troubleshooting, and I'll give you a couple of seconds to have a look at this before so if you can see in that configuration what the issue is as to why we do not see 2222 in our routing table in Leeds, please let me know now. So okay, to show you, I did this on purpose because I wanted to show you this. Over here, look, under the protocols, we've got AE0 and AE1, but we don't have the loopback, so the loopback isn't taking part in is. It's got the address there, the net address, but it's actually not participating purely because we haven't included it in the protocol. So let's go ahead and do that now. Add in our interface LO0.0. Okay, and we'll commit that. And now what we're going to do is we're going to go back to Leeds just for the moment, and we'll do a run show route 2222. And so now, because we've included it, we see it via is. Okay, we've got the metric. It goes to 1.5 first, which is correct, via AE 1.0. So now, can we ping it? Okay, sorry, it's because we're in configuration mode. Of course we can, because there's a route there now. But we don't see any others at the moment. And the reason for that is because we haven't configured is on them yet. So, for example, from London, we can't ping 3333. So if we try and ping 3.3.3.3, we won't be able to because there's no route to the host. Okay, and that's the Bristol system. So let's go on to Bristol, and we're going to do the same here. So we'll have a look at the configuration first. And as you can see, there is no is on there. So let's do the same here. So we'll go into edit mode and we're going to do set interfaces LO0 unit 0 family ISO address 49. Again, we want it in the same area 1. Now our unique numbers again. Now this time our address is 3.3.3.3, so let's put that in there. 3 3 3 3 and our this node on the end. Okay, so we can commit that. So now let's put our interfaces into the family ISO as well. So set interfaces AE0 unit 0 family ISO, and we also want AE1 in there. Okay, we can commit that now. Let's just commit that anyway. So now we set our protocols is interface AE0.0 AE1.0, but don't forget we need to put our loop back in there as well, LO0.0, and we can commit that. Okay, so the question is now, can we see the other interfaces? So let's have a look at run show root 2.2.2.2. There we go. It does take us a couple of seconds for the database to update. Okay, as you can see there. So we have 2.2.2.2 in there. Question is, do we have? Yes, we do. We can also get to 4.4.4.4, which means we can actually ping leads. Okay, and we're going via London to get to Leeds if we have a look at our diagram again. So we're pinging from the net address at Bristol. We're going across to London because it tells us it's going out of AE00. So it goes across here and it comes down to Leeds. Okay, the only place we won't see at the moment is 5555. So let's go back to Leeds and have a look at our routing table. Okay, so we can see 2222, 3333. So that's London and that's Bristol. It tells us how to get there, and that's fine. Okay, so it says to get to 222 via London, because it is London, via London, because that's the correct route. Okay, so at the moment we don't have the 5555 in there because we haven't yet configured Edinburgh. So let's go ahead and configure Edinburgh. So on Edinburgh, we do, let's have a look at the config as well so that you can see what we've got on here. So as you can see, we've just got the normal configuration. There's no actual is on there. So let's go ahead and do that. So let's set our Nsap Net Address first. So set interfaces LO0 unit 0 family. Unit 0 family ISO address 49. Area 1 we want. And on here we've got 5, so the next set of 3 times 4 digits, 5, and the node at the end, this node. So we can commit that. So again, we now need to include our interfaces into the family ISO. So let's do a set interfaces AE1 unit 0 family ISO. And we can commit that. Okay, let's also set our protocols of is interface AE1.0 and LO0.0. Okay, so let's commit that. And remember, it will take a couple of seconds. Let's do a run show root. So currently at the moment, we don't have a lot, as you can see up here. But let's give it a couple of seconds. Let's have a look again. Okay, so now we have them all appearing. So we have all our loop backs because they've all been included in it. Okay, and it's the same coming down. Okay, so we should now be able to ping 4444, and it will tell us it's going via Bristol. So it will tell us it's going out. So we're going to ping from Edinburgh. It will tell us AE1 here, across to London, and down to Leeds. Okay, so let's run ping 4.4.4.4. And there we go. Okay, so we have communication throughout the network now from an is perspective. I was going to leave it to a later lesson, but we can include it now just to quickly show you what will happen if you get something wrong from an authentication perspective. So let's quickly run through that. So edit, set protocols, is. Now, what do we want to do? We want to do, at the moment, we're level 1, level 2. So let's do a level 1. And what have we got? Well, we're going to use an authentication key and an authentication type. So let's go for authentication key. Okay, and what does it want us to do? Just wants a password in there. So let's just put in there PASSWORD. There you go. Okay, now let's use the up arrow, level 1. We still want authentication, but this time we want authentication type, and it gives us MD5 and simple. Now, this will actually probably be a question in your exam if you're ever given this. What types of authentication are available under is, and it's MD5 and simple. Well, we're going to use MD5. Okay, and we're going to commit that. Now we're going to have a look at our routing table again. Which should actually, in a moment, run ping 4.4.4.4. Right, okay. There we go. There's a good bit of troubleshooting for you straight away. The reason that's working still, and the reason those routes are still showing, is because of a particular thing that I've missed. But the reason I've not edited that out of the lesson is because it's a good learning curve, okay, for you guys. So the reason that is still working is because these are level 1, level 2 routers. So it's still communicating over level 2. Level 1, we've done the authentication, but we haven't done it on level 2. So let's do that. So is level 2 authentication key, password, and the authentication type is going to be MD5. And we'll commit that. And now we'll have a look at the show route. Now, as you can see, all the routes have disappeared. And the reason for that is because we've actually put authentication on each system now. So what we need to do now is Edinburgh connects to Bristol. So let's do Bristol next. So on here, we're going to do set protocols is level 1 authentication key. It has to be the same across all systems that you want involved in this. So the password must be the same, and it must be the encryption type must be the same as well. So the authentication type is going to be MD5. Okay, we now need to do that on level 2. level 2. Let's commit that. Okay, so now let's go back to Edinburgh again and see if we see the routes for there. So as you can see, they've come back. Okay, so we've got our 3333 is back again via is. Okay, now we have to go to, let's do London next. Okay, so on London, we do set protocols is level 1 authentication key, got to be the same. Okay, and the type will be MD5. Okay, and level 2 the same. Sorry, I hit the wrong key there. Let's commit that. Okay, now if we go back to Edinburgh again, let's have a look and see what we've got in our routing table now. Now we've got London has appeared. Okay, London is back. And for our last one, we need to go to Leeds, and we need to, in here, edit, set protocols is level 1 authentication key, again must be spelt the same, and the type is going to be MD5. Okay, and the same with level 2. We can do it whichever way round we want, doesn't really matter. And we'll commit that. Now if we go back to Edinburgh and we have a look at our route again, what do we have now? Now we have all of them in there again, and we can now ping 4.4.4. Sorry, it's because we're in config mode, 4.4.4.4, and we're back to communicating again. Okay, so that is a very, very brief introduction to is and the basics of it and how it operates. What we'll do is in a later lesson, we're going to go more in depth into this and create different areas and have different routing levels from an is perspective. Okay, hope you enjoyed that lesson. Thank you. Bye-bye.